This is Science 8 readings for Lesson 4.3 WCS. The name of this article is called Toricelli, Inventor of the Mercury Barometer. The purpose for reading this article is to answer the question, does air have weight? Explain how you know using Toricelli's mercury barometer. Scientists and weather forecasters use barometers to detect and measure air pressure changes. The barometer is an old device, but is as useful as ever. In 1643, Toricelli, a student of Galileo, accidentally invented the mercury barometer in his efforts to create a perfect vacuum. At the time, there was great interest in determining whether air had weight, and if so, how much. Creating a working vacuum, a vessel entirely empty of air that did not leak, was a major technical problem, but necessary for determining whether a completely empty vessel weighed less than one full of air. So the first thing I need to do is circle the word barometer and know it's an instrument that measures air pressure. Note also, at the time, he was trying to make a perfect vacuum, not a barometer. Toricelli created a glass tube about 1 meter in length that could be opened at one end while closed at the other. Toricelli filled the tube with mercury and then inverted the tube in a pool of mercury. The mercury flowed out until the pressure from the mercury in the tube equaled the pressure of the air outside the tube. Over a period of several days, he discovered that the mercury rose and fell slightly in the tube. Toricelli correctly concluded that the pressure of the air outside the tube was pushing on the mercury in the dish, and that this pressure kept the liquid up into the tube. Because there was no air in the tube, nothing resisted the mercury's rise except gravity. In other words, the height of the liquid in the tube was a measure of atmospheric pressure. The greater the atmospheric pressure, the higher the mercury moved up the tube. Why did Torricelli use mercury instead of water as Galileo had done? First, water could evaporate in the tube, leading to false readings. Second, water is less dense than mercury, a metal, making a cubic centimeter of water much lighter than mercury. Remember, the thing that stopped mercury from rising all the way to the top of the tube was its own weight. A less dense liquid could rise much higher. In fact, an atmospheric pressure that first forced mercury 76 centimeters, 30 inches up the tube, could push water 1,034 centimeters, 34 feet high. A barometer that tall was clearly impractical. So Torricelli made a better barometer than Galileo because one, water could evaporate in the tube, because you remember Galileo used water instead of mercury. And the second reason why the barometer was better, because water is less dense than mercury. Torricelli's barometer was small enough to be portable, so weather observers could measure barometric pressure at different altitudes, which gave scientists of the day confirmation that air pressure did indeed vary. A unit of air pressure was named the torr after Torricelli. Today, scientists measure air pressure in units called millibars, MB. Each 1,000th of a bar, the air pressure at sea level. Thus, air pressure at sea level can be reported as 1.0 bars or 1,000 millibars. This is equal to 29.53 inches of mercury. End of recording.